All right, good morning, everybody. Happy Thursday. All right, so you have all watched the introduction video, letting us all know what we're going to be doing today and how today is going to look. Okay, now we're going to dive in to the remaining portion of chapter 18. So you're going to take this time to make sure that you have your book open. Yes, use your book. Yes, use your book. Why? Because the book is where we get our test questions from, right? So it is your go-to when studying for your test. All right. So we are going to pick up where? Where are we going to pick up? Right at the pancreas, huh? We're talking about, remember that? Insulin, glucagon. All right. And so although I'm recording, let's screen share. Hold on. Hada. Here we go. Let's see. All right. Okay, here we go, right? This is where we left off. So I want to encourage you, while we're going through the chapter, finishing this chapter up, I'm going to ask you questions, answer it. Pretend that I can hear you. Pretend that we're talking, okay? Engage in a conversation so you're actively learning. Do you know that when we are trying to retain information, having conversations about interesting facts increases retention? Did you know that asking questions increases retention? That explaining a fact as though you were explaining it to a child increases retention, right? And that's why I tell all my students, let me see, what do I tell them? I tell them, one moment, please. To retain information, you need to read it. Where do we get that? The book, right? The book. You need to read it. Oh, that's a star. You need to, let me make one just as messy. Write it. You need to say it out loud. That's why I want you to talk. And then, anybody know? What was that? You need to teach it. Okay? Read it, write it, say it, teach it. These actions, they've been studied. It has been proven that doing this on repeat will aid in retention, okay? All right. So, here we go. So just a quick little recap. Remember, we got your pancreas, right? Big old factory that has all these sub-factories, right? One of their bigger sub-factories are the islets of Langerhans, okay? The islets of Langerhans also has two little sub-factories, production factories, the alpha factory and the beta factory, okay? The alpha factory are a bunch of alpha cells that produce a product, a hormone called glucagon. My friends, what does glucagon do? It's going to raise blood sugar, right? Yes. Your beta workers, your beta cells, what do they produce? Insulin, the hormone insulin. And what does insulin do? It decreases, yeah, it decreases blood sugar, okay? All right. Now, how does insulin decrease blood sugar? Well, remember that Snickers bar we talked about last class? You eat that Snickers bar, and where does it go? It's going to get digested, right? And then it's going to end up in your bloodstream, coursing through your body. You got Snickers going everywhere, right? So all of these green dots with X's, those are your Snickers, okay? Insulin, what insulin is going to do It's like it's time to go to work. I'm going to take that insulin sugar, or not insulin, that Snickers sugar. I'm going to take it and I'm going to add it. I'm going to give it to the body cells. Any extra, any extra Snickers sugar, glucose, we're going to hand it on over to the liver. Why? Because the liver has this really rad pantry. Okay. And it's there that glucose, the usable sugar, gets converted into glycogen, the stored starch form of glucose. And there's my pantry. Remember that? Don't erase. Boop. Okay. So, what does glucagon do? Glucagon raises blood sugar. So, wait a minute. Somehow we got to get this pantry, this stored starch, over here into the blood. How are we doing that? Y'all think about it, man. What is this glycogen? It's like baking soda or yeast, flour. On its own in the pantry, it's probably kind of nasty. Like you're not going to just go take a spoonful of yeast, right? You're not going to take a spoonful of flour. Um, no, but it is an essential product to keep in the kitchen, the body, right? It's an essential product, but it's the stored form. We need to make it usable, the bread, the cake. We need to turn it into a usable form. So that flour, egg, and water will get converted into a usable product, that cake, right? So glycogen is a stored starch that's going to get converted to glucose. And where is it going? Back into the blood. So insulin can do what insulin does and give it to all our body cells. Thank you, insulin. Cool? All right. All right. Take a second. If you have a question, write it down. Pause me right now. Okay. Welcome back. So let's recap. The islets of Langerhans, super weird name, right? Produce insulin and glucagon hormones. Insulin lowers blood sugar by promoting movement of glucose into the cells and promotes storage as glycogen. Remember, what is glycogen, my friends? That stored version of glucose. Okay. Glucagon, the hormone, so many G words, huh? Glucagon promotes the movement of glucose, sugar, like the usable stuff, right? The good sugar. Like you can take a spoonful of sugar, just a spoonful of sugar, right? You can take a spoonful of sugar in your mouth. You can't take a spoonful of like flour. I mean, you could, but it wouldn't be very enjoyable. Okay. So glucose is usable right there. Like, bam, let's go. Glucagon takes glucose into the blood by breaking down glycogen that are stored in the pantry in the liver cells. Okay, again, glucagon, the hormone, promotes the movement of glucose into the blood by breaking down glycogen. And this sentence is a little bit backwards, isn't it? What we could say is glucagon breaks down glycogen into glucose and brings it to the blood. Okay, so again, glucagon, the hormone, is going to take glycogen, the stored starch found in liver cells, the pantry, and it's going to break it down into a usable form, glucose, bringing it to the blood, where insulin is going to do what insulin does. Bam, 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 right? Bring it to the body cells. Cool, cool. All right, here's all the G words. Okay, glucagon, hormone, glycogen, stored form, glucose, sugar. Okay, all right. And again, like we talked about, these two hormones, what are they doing? They're doing like straight up, dude, the exact opposite of each other, but in like perfect harmony, unless somebody has diabetes. perfect harmony, creating a state of what? What's that word? Come on, say it. Come on, boo. Say it. Say it. Let me hear it. Give it to me. Homeostasis. Yes. What is homeostasis? Homeostasis is all good in the hood, dude. It's all good. Everything is as it should be, right? So, not too much insulin action, not too much glucagon. We are all doing what we should be. Nobody's acting out. It is good. Homeostasis. All right, let's go. Remember, if you have questions, pause me. Hang on, I have to sneeze, but I can't pause. Hang on. Oh, pardon me. Okay. So I know my drawing, there was a lot happening there. This one right here, and you can go back to it. Okay, here you've got the organ, the endocrine organ, the pancreas, that has special cells called the islets of Langerhans that produce even specialer, is that a word? Even more specialized cells, the alpha and beta cells. These alpha and beta cells produce hormones, glucagon and insulin, okay? All right, now here it's a little bit cleaner looking, huh? So we have the pancreas, that endocrine organ, that produces insulin and glucagon. Insulin by the beta cells, glucagon by the alpha cells, okay? What does insulin do? Lowers blood sugar, turning glucose to glycogen. Glucagon is going to raise the blood sugar. How? By changing glycogen, the stored pantry form, to glucose, the usable form. Whee! Okay, moving on. Pause if you need to take notes. Oh, hey, sidebar, let's go. So, super side note here, but kind of cool. If you know anybody that's a diabetic or somebody whose blood sugars can go way up, way down, borderline diabetic, or you find somebody that has a super low blood sugar, or you are suspicious that they might have low blood sugar, a really neat little trick that we used when I was actually working in the field was giving the patient a fast sugar and a slow sugar. What? There's a thing? Yeah. So fast sugars are going to be your Snicker bars, like straight up sugar. Okay. Donuts, juice, candy, fruit. Okay. Active, real sugar. Then we have your starches, your carbs. Those are slow sugars. Okay. And they don't get metabolized as quickly. Now, why would I give somebody that if they have low blood sugar? Well, I wouldn't just give them that if I had a fast sugar as well. I would do both because look at what happens. So let's erase. I'm gonna erase this. Okay, look. So when we look at a fast sugar, we'll go red, okay? Their blood sugar is down right here, okay? So it's nice and low, or really low. With a fast sugar, what's going to happen when we take it right here? It's going to go up, whoop, and then down. And a lot of times with diabetics, it's not going to just go down, but it's going to go even lower than it was before with fast sugar. Uh-oh. So what we like to do is at the same time, if we can, give a fast sugar with a slow sugar. So maybe at the same time as a small cup of juice, I may also give some rice or a slice of bread, glass of milk. And what's going to happen, what you're going to see, it's going to go up slower and drop slower. See that? And it helps the patient to stabilize their blood sugar. So little trick. Comment or thought, question, go ahead and pause, okay? Okay, we're going to totally change gears here and talk about the pituitary gland, okay? All right, This pituitary gland is a small pea-sized gland located at the base of the brain. Base. What's a base? It's a base at the bottom, huh? Okay. So at the bottom of the brain, in a small pocket-like depression, okay, of the skull. This pituitary gland has two parts. The anterior. What's anterior mean? Come on, say it. Say it, say it. Ready, set? Front. Yes, good job. Anterior lobe is a front part of the pituitary gland, and then it has a posterior lobe, right? Which is what? The back side. So remember the adrenal gland had the medulla and the cortex, right? The inner and the outer. Two different parts with different functions. One was inside, one was outside. Well, with this gland, we like to, switch it up. So it's going to go, or not goes, pardon me. Instead of inside and outside, this is going to be front and back. So the front has a different action than the back, the posterior. Okay. All right. So the hypothalamus, a region of the brain under the thalamus, hypo, below, less than, right? The hypothalamus, a region of the brain under the thalamus and above the pituitary gland, okay? This hypothalamus signals transmitted, I'm sorry, I didn't even say that correctly. Let me boop, 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 back it up. Signals transmitted from the hypothalamus control secretions by the pituitary gland, okay? So the hypothalamus has a big role, a big job when dealing with the pituitary gland, okay? So the hypothalamus controls secretions of the pituitary gland by releasing factors, by other hormones, okay? All right. The big takeaway here is that the pituitary gland has a lot of really important jobs, okay? In a lot of textbooks, they're going to call it the master gland of the body, okay? The master gland of the body, because it makes hormones that control several other endocrine glands. But I'm not a fan of that term, so I like to call it like the prime gland or the main gland. Like it's an important gland, but not the master gland. So anyhow, but do know, it is important to know that it is referred to as that in case you see it on your test. Okay. Now let's talk about why it is such an important gland, why it is such a prime gland in the body. Okay. So again, we have the anterior lobe and the posterior lobe. I'm not going to ask you about the adenohypophysis, okay, or the neurohypophysis. You don't need to know these terms. Just know anterior lobe and posterior lobe, okay? And here it is at the base of the brain, okay? Let's see here. So I want to show you, remember we were talking about that hypothalamus? The hypothalamus secretes hormones directly into the pituitary gland for secretion, right? So for dispersion to the body, the hypothalamus is using the pituitary gland, okay? All right, here we go. So we're going to first talk about the anterior pituitary, so the front portion of the pituitary gland, okay? There's a couple of hormones that I want you to be familiar with. The growth hormone and adrenocorticotropic hormone. Big old word, adrenocorticotropic hormone, ACTH. Okay. The growth hormone is going to be that hormone that is going to tell our body, promotes the protein synthesis that results in the growth of bones and muscles and body tissues. Okay. Growth hormone dramatically slows down and then totally stops when we get to a certain age. But we still use growth hormone in certain structures that do need to continue growing. So, growth hormone also stimulates the liver to make insulin like growth factor, which stimulates the growth of bones. It increases blood glucose levels and is secreted during exercise, sleep, and hypoglycemia. Anywho, growth hormone, growth hormone pumping through a child's body, right? Going from 3 feet to 5 feet, 6 feet, okay? Growth hormone. And then we have your thyroid stimulating hormone, TSH, okay? Again, remember, this is like the main gland, the master gland of the body. Why? Because it stimulates the growth of the thyroid gland and its secretion of thyroxine. And again, what is thyroxine? Come on, like, get those brains moving. What is thyroxine? Thyroxine is going to be the hormone that increases metabolism of body cells, right? Okay, so totally random different hormone and different organ, but you can see how this pituitary gland plays a big role in other structures, okay? Then we have the adrenocorticotropic hormone, ACTH, okay? Now, ACTH, what does it do? It stimulates the growth of the adrenal cortex. Where is that? Come on. Think. Pause me if you need to. Where's the adrenal cortex? And increases the secretion of steroid hormones, primarily cortisol. Okay. Okay. So the adrenal cortex, the outer portion of the adrenal gland. Okay. So again, another structure that is being impacted, influenced by the pituitary gland, okay? So then we have the gonadotropic hormones, FSH, LH. You learned about these way back in chapter 8, huh? And what, chapter 7? 7, yeah. 9 was urinary, 8 female reproductive system, and 7 male reproductive system. Okay, so the gonadotropic hormones are going to influence the growth and hormone secretion of the ovaries in females and the testes in males. Okay, all right. Then we also have the FSH in females and LH in females that stimulate the growth of eggs and the production of hormones and ovulation. Okay, prolactin stimulates breast development during pregnancy and sustains milk production after birth. Okay. All right. So now that's the anterior, the front portion of the pituitary gland. Bam, there it is. Okay. There's probably going to be 2 that we talk about. Here we go. Let's talk about posterior. All right. So the posterior pituitary gland stores and releases 2 important hormones that are synthesized in the hypothalamus. Okay, y'all, dude, listen. I'm going to say it again. I want you to hear this, okay? Pause if you need to get centered and focused. The posterior pituitary gland stores and releases 2 important hormones that are synthesized in the hypothalamus. All right, hada. Why the heck do I have the word gallbladder and liver here? I'm going to tell you. So my question is, this is my question. I want you to answer it. Pause me if you need to. The posterior pituitary gland stores and releases two important hormones that are synthesized in the hypothalamus. Antidiuretic hormone, ADH, also called vasopressin, and oxytocin. Okay, this is my question. Does the posterior pituitary gland make ADH, antidiuretic hormone called vasopressin, and oxytocin? Does the posterior pituitary gland make those hormones? I mean, we're talking about the posterior pituitary gland and what it's secreting. Does it make those two hormones? Pause me if you need to. No, it doesn't. Because we're learning that it's storing and then releasing these two hormones that are synthesized. Y'all, what does synthesized mean? Synthesized means made by, produced by, manufactured by, right? So the posterior pituitary gland is kicking out, pumping out these two hormones that are made by the hypothalamus. So why the heck am I mixing y'all up by writing gallbladder and liver up on this board? Because I want your brains, your beautiful brains, to go all the way back to chapter 5. Yeah. And just think for a second. I'll help you. It's the same concept with the liver and gallbladder. Because remember, what does the liver make in relation to that gastrointestinal system, the digestive system? What does it make? It makes, come on, get it? What does it make? Bile. Yes, it makes bile. So the liver makes the bile, right? So it synthesizes the bile, just like the hypothalamus synthesizes antidiuretic hormone and oxytocin. And then check it out. The liver is like, yo, gallbladder, what's up, homie? Let's go. What is it going to do? It's kicking it on over to our fanny pack gallbladder. And the gallbladder is like, I got you, boo. I got you. Okay. So I'm going to hold on to it. I'm going to store and concentrate that bile for you, right? And when our body needs it, bam, 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 I'm going to kick it on out. So, dude, check it out. Look. The posterior pituitary gland, I'm going to read that sentence again, stores and releases two important hormones that are synthesized in the hypothalamus. Same concept. It's a totally different body system, right? Okay, so let's talk about what these two hormones do. So ADH, also known as AKA vasopressin, okay? Vasopressin stimulates the reabsorption of water by the kidney tubules. It also increases blood pressure by constricting arterioles. Oh man, we're going way back. Okay. What does that mean? Remember, we talked about that last class. If you got, look, let's go, bam. You got two blood vessels that have the exact same amount of blood going through it. So let's say three strips. 1, 2, much more concentrated with a constricted arteriole. What is an arteriole? Come on. Pause me, baby, if you need to. What's an arteriole? The itty bitty teeny weeny what? Arteries. Good job. All right. So vasopressin pressed in together tight, little, makes vaso. What's vaso? Vessel, blood vessel. Yes. Okay. Going to constrict these arterioles, make them small, and the antidiuretic hormone is going to add more water to the blood. So more water, more fluid. Look, not only did we constrict their arteriole, but with more fluid, what did we just do? Increased blood volume, which is then gonna what? Increase blood pressure. Cool. All right. Check, check, check. All right, then. Any questions? If you do, write it down. Pause me, write it down. Good job, everybody. Good job. All right. Then we have the ovaries and the testes. We don't really need to talk too much about them because you know what? I know you're all rock stars, and I know Barbara was teaching you, Miss Barbara was teaching you like incredibly, and you got your stuff, you know your stuff, right? So I'm just gonna bam, like real quick go over this, okay? Um, Ovaries produce a couple of different hormones, estrogen, also known as estradiol, and progesterone, okay? Estradiol promotes female sexual characteristics, and progesterone maintains pregnancy, okay? You're going to see some of this on your test. In the testes, testosterone is produced, okay? What does testosterone promote? Male sexual characteristics, okay? All right. Those sexual characteristics, deepening of the voice, body hair, pubic hair, development of sperm, okay, et cetera, et cetera, et cetera. Okay, good stuff. Guess what? That's it. You did it. You did it. All right, so now what we're gonna do, I'm gonna get on over to these combining forms, okay? Look, here's my secrets. If it's highlighted, you need to know it. There it is, okay? Adeno gland. Adenitis, what is that? Come on. Itis, inflammation, inflammation of a gland, infection of a gland, okay? Adrenal gland, okay? Gonado, sex glands. So remember in chapter 8 and 7, we learned that the ovaries and testes are both called what? Gonads. Why? Because they're sex glands. So women, females, have gonads as well as males. Okay, so men and women have gonads. Those are the sex glands, the ovaries and testes. Okay. Thyro and thyroido both mean thyroid gland. Let's see here. Dipso is thirst. So look at this. Take a look at this term. What's Ia? What does Ia mean? IA? IA. Ia. This is a old school suffix that you learned way back in midterm A. Condition of. What's poly? Come on, say it. I can't hear you, but just say it. Come on, baby. Poly is many, much. And we know dipso means thirst. So what the heck is polydipsia? Condition of much thirst? Oh. Mm-hmm. Who might we see that in? Diabetics. Polydipsia is going to be a symptom of diabetes, okay? All right, glyco and gluco both mean sugar. So again, this was also midterm A, hyperglycemia. So remember, we just talked about it. Ia is what? Condition of, but then you add an im in front of Ia, what do you get? Blood condition. So now we know this is blood condition. Hyper is what? Too much, above, more than. Let's say too much. So what is hyperglycemia? It's going to be condition of too much sugar in the blood, right? Look at that. And hypo, whoa, buddy. Hypo would be the exact opposite condition of too little sugar in the blood. Good job, everybody. All right. Lacto, milk. Prolactin. What is prolactin? Where is prolactin produced? Say it. Right. Somato, body. Uro, urine. Okay. And then again, emia, blood condition. Urea, urine condition. Glycosuria. What's glyco? What's glyco? Come on, say it, say it. Ea condition, urine. Urea, urine condition. Just like emia is blood condition. Urea, urine condition. So what is glycosuria? Sugar in the urine. Good job. All right. All right, some prefixes that are important to know. EU, good in the hood. Normal, as it should be. Everything is good, okay? Utopia, euphoria. Eupnea. Remember chapter 12, respiratory. Pnea, P-N-E-A. What was that? Come on. What is it? What is it? Breathing. Eupnea is normal breathing. Good. Okay, hyper, excessive above. Hypo, deficient below. Okay, poly, much or increased. Tri is 3. Tetra, 4. Interesting, huh? All right, we're going to stop here. Let me come back to you. Stop recording. All right, you can take a 5-minute break, come back, and we'll go into the disease processes. Okay, it'll be a second video. All right, good job, everybody.